So, okay, without further ado, let's welcome Sam Barron, as professor at the University of Melbourne, for his talk on what is time, just joint work.
Thanks, Igor, and thank you, Baptiste, Annika, and Chris for organising this amazing workshop in this amazing place. I'm always pleased to represent the entirety of Australia at these events. So this is a much bigger project than what I'm going to talk through today. I have given Marta the full project. This talk will be what I'm calling the Champéry approximation as time goes to zero. So here's the full account in all its glory. And there's an interesting phase transition that happens as we get down to very small amounts of time, something kind of stable and nice pops out. Okay, so why do we need an account of time? Haven't we already spent 100 years doing this? Well, one of the reasons why I want an account of time has to do with the work that lots of people in this room have been doing on space-time emergence, that I've been doing. Sorry, Chris, that my LaTeX macro wiped out the umlaut, but this is the Australian version. You know. So space-time might be emergent. It seems to be a popular view when we're looking at various theories of quantum gravity. But one thing that I've always kind of assumed is that if space-time is emergent, then time is emergent as well. But I don't think that that is necessarily guaranteed, because it kind of depends on what you think time is. And it could be that space-time is emergent, but that time itself is not emergent, that it remains at some fundamental level. Although I've spent a bunch of time arguing that time doesn't exist, that it's a kind of illusion, I'm actually increasingly skeptical of the idea that time is an emergent phenomenon and not something fundamental. But if time is more fundamental than space-time, it just sort of raises this question, what is time? What do we mean by time? And what I want is something that allows me to sort of go to a physical theory, like loop quantum gravity, or causal set theory, or the mad dog Everettians, and look to see if there's time still kicking about in their theory. So that's sort of the broad motivation. Here's a natural approach you might take to answering this question. You could just pick up your favorite theory of time from philosophy and say that's what time is. So you could say that time is an A series, it's a B series, it's a C series, all of those views are defended. You could say something like space-time contains time, time is a certain component of space-time. So you can take this approach. One reason why I don't like this approach is that I think that time is multiply realizable. When I look at each of these cases, a world with an A series, that seems like a world with time. I look at a world with just a B series, that seems like a world with time. A world with just a C series, that seems like a world with time, and so on. But if time is multiply realizable, then just grabbing your favorite theory of time and using that to answer the question, what is time, is not going to be very good, because what you're doing is you're giving a theory of something that's multiply realizable in terms of a particular realizer, which just leaves the question of what the thing that is multiply realizable ultimately is. More generally, what this does is it motivates a functionalist account of time. Right? This is a standard move when we strike multiple realizability in the philosophy of mind or anywhere else. We start to think, well, there must be some more abstract thing that we can pull out of these various realizers, specify some functional role, and then say time is the thing that plays that kind of functional role. That's roughly what I'm going to do. One of the things that I think is important is that space-time is kind of special amongst those options that I talked about. I think space-time contains time, but it isn't time. So it has temporal structure embedded in it, but I think it would be weird to say that the entire four-dimensional manifold just is time in some sense. So what we want is an account that can accommodate the multiple realizability of time, but that's still sufficiently sensitive that it actually pulls time out of the spatio-temporal structure. It allows you to say what bit of space-time is time, if any. There are some attempts to do this. So other people have thought of developing functionalist accounts of time. I'm not the first person to think of this. There's two accounts that I'm just going to briefly mention. I'm not going to go into a huge amount of detail, beating up on these accounts. If you want to do that in Q&A, we can. It's kind of fun. The first view is Craig's view in What Makes Time Special, where he says, time is the great informer. It's important to note that Craig is not trying to give an account of time in quite the sense that I'm trying to give an account of time. What he wants is an account of time in the following sense. You look at the spatio-temporal manifold, and you look at the various directions or dimensions that you have, and you ask the question, which of those is the temporal dimension? So that's part of what I'm doing, but I'm looking for a more general account of time that enables you to do that, whereas he's only trying to do that. So he's never sort of in the business of giving you an account of time that will cover off all of the different things that you might think count as time. He's really just looking at individuating temporal structure out of space-time. Still, we could take his functionalist account as an account of time in the sense that I'm looking for, a metaphysical account of time. And if you do that, then I think you end up with sort of misclassifying cases. I think there are some cases that look like, to me, they have time in them, but his account says they won't have time. So more specifically, his account says that time is the great informer. In this sense, if you're given a manifold, like a four-dimensional manifold with a metric, Lorentzian metric over it, time is the direction in that manifold along which the laws of nature take their simplest and most informative form. What does he mean by that? Ultimately, what he means is that there's a particular direction in the manifold where if I give you Cauchy data, you can fully specify the rest of the manifold. So he thinks that time is the direction in which it's sort of orthogonal to the surfaces in which you have well-posed Cauchy problems. If that's what you think time is, then I think that there are some cases where you just won't, this will just say that there's no time. One of them is that if you have lawless worlds, worlds that just don't have laws in any sense, but even if you have worlds where the laws might be tying for simplicity and informativeness along directions, one of the things about his account is it demands uniqueness. So you won't ever be able, if you've got two things that satisfy it, then the account's going to fall over. It also really requires this sort of manifold structure with a metric. So if you've got anything, like if you've just got a topology with no metric structure over it, his view is going to say that there's no time in there. I think that there could be worlds like that. I think some of the causal set theorists think that their view is a view of time, but it's just topological, even if it gives you metric structure later on. The one that moves me, but may not move so many people in this room, is that if you tie what time is so closely to physics, you're going to rule out the A theory and rule out the A series, arguably. I think because the A series is very hard to accommodate inside this sort of picture that he's got. But I think the A theory is time, if it were true. Another example is a recent paper by Gomes and Butterfield where they say something like this. They give a few different functionalist analyses. I think this is the most well worked out one in that paper. Again, they're not trying to do what I'm trying to do. What they're interested in doing is looking at shape dynamics in particular and trying to work out if there's time in shape dynamics. So like we have overlapping interests, but I want this broader metaphysical account rather than something that just works for a particular theory. And so they say that, and then kind of motivated by Aristotle here, time is the measure of changes in spatial geometry. So it's the sort of this parameter that takes your fluctuating spatial geometries and allows you to parameterize those. So this does cleave time out of space-time. There is a particular direction in the manifold that is going to do this work for you. But it has some interesting implications. It's going to tell you that you can't have a world that just has time in it and no space. It's going to rule out, as far as I can see, time in worlds with fixed spatial geometry. So if you've just got a Newtonian world where there is no change in the spatial geometry, then time is not going to be a measure of anything. It's also, I think, again, going to rule out these A-series type pictures because it's tying time so closely to something in physics. So again, what I want is an account that does some of the work that these two accounts do, but still accommodates enough of the things that I think time can be like the A-series. But also just, I think these are, if you don't like the A-series, I think some of these can motivate you as well. Okay, so here's the view that I'm toying around with. This is the slogan version of the view. The slogan is easy to state. Time is an enabling condition. So Craig thinks it's the great informer, I think it's the great enabler. What I think time is doing is it's there to make causation and change possible. That's the functional role for time. That's its job description. And I'm going to call time the great enabler because other things plausibly enable that sort of stuff as well, but time does it in a very special way, and that's why it gets to be the enabling condition, in the sense that when time is doing this work, it's in some sense indispensable. Okay? Making this precise is super hard. I'm going to give you an attempt to do that. I'm not going to give you the full account. I'm going to give you as I said, the Champéry approximation, which is a much simpler version, just to handle the case of space-time. But it has a lot of bells and whistles to actually try and get this to work, to cover off the full amount of things that you want to count as time. Before I get there, I just want to address this question. Why causation and change? There's lots of things that you could tie time to if you're thinking of specifying a functional role for time in this sense. I like causation and change. I mean, historically, causation and change are the two things that have been linked to time the most often. It is the things that people keep coming back to as something that is connected to time in some sense. But I also think that these two aspects get us something. So causation sort of captures the connective aspect of time, the sense in which when you've got time, things can enter into relations of dependence in a certain interesting way that we use and manipulate in experimentation. And then change captures the variational aspect of time, the way that things can differ from one temporal location to another. So these two aspects are sort of capturing some nice features of time. I should say I don't demand both of these things. So time can enable, the and on the slide should be read as an or. As long as time can enable one of these things, or as long as something can enable one of these things, then it gets to be time. It can enable both, but if it just enables causation in a world, that's fine. If it just enables change, that's fine as well. Lots of other things you could add. Happy to talk through your favorite thing that you might want to build into the functional role for time. Okay, so here's the account sharpened. In some sense, it's kind of old school. I'm going to use this. Inus conditions from Mackey. I feel like we didn't spend enough time using Inus conditions for other things. So Mackey used it for causation. I'm going to use it for time. So I'm going to break these three things down. The first thing that there's some structural feature. So I don't want to suppose that something's time. I'm just looking what is the structural feature, and then I'm giving you some conditions so we can work out whether it's time or not. So the first one is that it's a strong Inus condition. So an Inus condition, if you don't know, is an insufficient but necessary component of an unnecessary but sufficient condition. That first N is not like the magician's N, it really means indispensable. So you've got a sufficient condition, so think about you're striking a match and it causes the match to light. The striking is necessary in the sense that if you were to remove the striking, then the rest of the stuff wouldn't be able to bring about the fire. But it's not necessary for fire, right? Because there could be other ways to produce fire. Then F has to have a certain structure, which I'm going to talk through, but I'll give you a sense here. The L is location, so I think time is a place for things to be. So you have to have a structure of locations. These relations here are whatever relations you need for location. So things like adjacency, neighborhood relations. Pick your favorite locative structure. I don't really want to give an account of location as well, so I'm happy to take whatever the going account of location is off the shelf and use that here. And then these are the features that you add to that structure of locations that then get it to do the enabling work. So this might be an earlier than relation, or it might be some other relation depending on what it is that you're interested in. Then the last condition is that it's this technical term, roll core. This just means that, as we'll see, it has to be a certain size to do the work. Okay, so let's break this down. What do I mean by a structural possibility? Well, the kind of thing that I'm trying to capture here is that the idea that you can have an empty world that still has time in it. So you can have a world that, as a matter of fact, lacks causation and change, but it could still have time in it because it could, there are possibilities with respect to that world that involve causation and change. So structural possibility, in this sense, contrasts with what I'm going to think of as an existential possibility, which is just where you've got all of the causation and change inside a world. The structural possibilities are specified in terms of configurations. So you've got this structure of locations, and you can imagine pinning stuff to it. You can pin objects to it, fields, whatever you like. But then you can also pin causation facts. So there's going to be a set of facts that specify which things stand in causal relations. And then you can also pin change facts, a set of facts that specify which things are changing and which things aren't changing. Now we've got this notion of F admissibility, which is just the relevant notion of possibility. So one of these configurations is F-admissible just when you can have a world with both the structure and the configuration co-instantiated. That doesn't mean that when you're in a world they have to be there together, it just means that you can sort of get to a world where you can have those configurations with the structure. An important thing here is that the kind of change facts, the kind of causation facts I'm interested in, I'm going to draw this distinction. I'm not sure this is the right terminology to draw this distinction between qualitative and quantitative information. What time does is it tells you which facts can occur, which causal facts can obtain, which change facts can obtain. What it doesn't do is tell you how they happen. So it doesn't tell you how fast causation happens, it doesn't tell you how fast a change occurs. So there's sort of two jobs here. One of them is a kind of enabling job, one of them is a calibrating job. Time's role is to enable causation and change. It's not to calibrate causation and change. That's going to be done by something else. This is going to be super important when I deal with the space-time case, actually. Part of the reason why I want this is because it's reverse engineered from a certain case, but also I think that these quantitative facts, these facts about which things happen, are more fundamental than the sort of qualitative facts about how they happen. Those could be, you could have the same facts about which things occur, but with different facts about the rates and things like that. So I'm sort of getting time to be activating the kind of basic features of causation and change. Okay, so Innes conditions. So an Innes condition, as I said, is an insufficient but necessary component of an unnecessary but sufficient condition. Sorry, I've got pictures of this. The reason I want this is because time alone is unlikely to be sufficient for causation and change. You're probably going to need to, if you just have time, probably you're not going to get anything interesting happening. You're probably going to need to combine it with things like matter, things like laws, things like space, maybe. And so it can't just be the case that time is sort of an enabler and that's all we say. We have to split it from other things that are going to be in the package that are doing the work. So that's why we have this Innes condition, this idea that yes, there can be other things that are helping to enable causation and change, but time is the thing that's really important and essential to that package. It turns out that a plain Innes condition won't do. So what I've had to do is strengthen this notion in a way that enables me to split time from other things. And so the strengthening is, so the normal account of an Innes condition is just that you've got a single sufficient condition and time is a component of that. The strengthening is that for every minimal sufficient condition, every sufficient condition that contains time that enables causation and change, time is essential to every one of those conditions. That's not to say that time is necessary for causation and change. It's just to say that whenever time is doing this work, you can't get rid of it and have the work done with what's left over. Okay? So here's the picture. That's a plain Innes condition where T is just this sort of necessary component of this package, and then what we're interested in is we can modalize it basically so that whenever we've got one of these sufficient conditions, time is playing that role. This goes beyond Mackie, might even make Mackie turn in the grave. Okay, so this is just the technical statement of this. I've done it in terms of minimally sufficient conditions. That's the same thing as specifying an Innes condition. This is just the basic notion, and then this is the strengthening. There is another strengthening that I'm not going to talk about today, which is the microwave taped to the back of the bicycle. But if you're interested in certain edge cases, I will wheel it out and we can talk about it. Okay, so just to give you a sense of how this works, think about whether matter satisfies this thing. So you could have, if you just had a single Innes condition, it could be that both time and matter are essential to that Innes condition in the sense that if you take the time part out, you don't get any causation and change. You take the matter part out, you don't get any causation and change either. But the thought here is that take a world where you've got sort of time, space, and matter, and you pull the material component out and you just go back to having time and space. Well, this is still an accessible world. There's the world where you could then pin the matter back into that world is still possible because you've got the structure to do that. Whereas over here, if you've got time, space, and matter, and you pull the temporal component out and you just have space and matter, then the thought is that you won't have enough structure left to enable causation and change because you don't have sort of roughly anywhere for that to happen. So this is how you get the split between time and matter by using that strengthening. Okay, the structure of locations. So the structure here is just a bunch of entities that can function as locations. So whatever, as I said, you take locations to be, whatever you take that structure to be, they're going to be organized by these relations, and then you've got these additional structural features that sort of that switch on the causation and change. So here we've got some like neighborhood relation over these locations, and then we've got an earlier than, and then two configurations where you're just pinning different facts. So here I've got one where you're pinning change facts, here I've got one where you're pinning causal facts. These are two admissible configurations given the base structure. Okay, this last condition, this roll call condition, it's a little bit complicated, but the basic idea is that time is the perfect size. So anything bigger than, if there's something bigger than a structure that enables more, then that thing gets to be time. And if there's anything smaller that enables the same, then that thing gets to be time. So in other words, something gets to be time when there's nothing bigger than it that enables more, and nothing smaller than it that enables the same. So it's sort of got this Goldilocks feature where it's exactly the right shape and size, well, right size, I'm not going to say shape in this room, exactly the right size to do the work. This is made precise by this notion of a substructural part. So you can get a substructural part by either restricting the location set that you have to some subset, or so think of the B series as like a timeline and just like cut down to an interval. That would be a substructural part in the first sense. The second notion of a substructural part is a little bit trickier, and the idea here is that you can define some structure from the structure that you start with, but that structure you define, but not vice versa, so there's a one directional definition here. And that structure that you sort of define down to has relations and features of the same type as the structure that you started with. So you have to have this sort of type matching, but you are losing information as you cut down. But it's not necessarily by removing locations, it's just by kind of stripping out some other information. Type is quite a rich notion here. So arity of properties, algebraic properties, qualitative features, whatever you like. Okay, so this is just the visualization. Here we've got something that's enabling exactly, it's sort of the right size. This is something bigger. If it enables more, then this wouldn't count. If this enables less, then this does count. So we get something that's sort of sitting in the middle in the right way. Not too big, not too small, just right. Okay, so I'm going to just quickly talk through the space-time case and then finish up. So here's how I think this applies. So suppose we've just got a space-time with a manifold and a metric over it with a standard Lorentzian signature. What we can do is we can define out the causal connectability relation, which is the light cone structure of the space-time. So just define up this thing that takes all of the time-like and null curves, and then we consider that substructure of the whole thing. So that's not all of the information in space-time. That's a sort of something that we can cut down to, because we don't need to specify this in terms of metric structure. So we can drop down to this thing that has doesn't have metric structure, but sort of retains the causal connectability structure. And so we can define down to here, but we can't get back to here with just this information, okay, just the causal connectability information. So my claim is that this substructure of space-time is the thing that's doing all of the enabling work with respect to causation and change. So if you look at that causal connectability structure, it's the thing over which we paint causation, it's the thing over which we're going to paint change, and so that's the thing that enables the possibilities for causation and change in space-time. The rest of the information, the full metric, it adds more information, but it's not going to add information about which causal facts and which change facts occur. This is where that distinction between qualitative and quantitative information is really important. What you will have with the metric is things like parameterization, so you can talk about the rates of the changes and the rates of the causation, but you're not getting extra causal information, extra causal facts about which causal facts attain. You can just talk about how fast or slow they're attaining. So we don't get extra possibilities in my sense, even though that extra metric structure might give you more information about causation and change. So this substructure is going to satisfy this Inus condition, at least for space-time structures. So if you take a space-time and you pull that causal connectability structure out, what you're left with is not sufficient to enable causation and change in any of the space-time structures that look like that. And so you're going to have something that satisfies this stronger Inus condition. Also, this is a structure of locations that's pretty straightforward to see, I think. This substructure, I think, also satisfies this roll core condition because nothing bigger than it enables more. The only thing bigger than it is the full space-time, and as I said, this isn't giving you more options for causation and change, it's just giving you more information about how those things might happen. And there's nothing smaller that enables the same. If I cut down the causal connectability structure by like stripping out the locations or trying to define up some other substructure with the same relation, we're going to lose places for things to happen, very roughly. We're going to lose information about where causation can occur, where change can occur. And so this substructure is going to enable strictly less than the full structure is going to enable no more, and any substructure is going to enable strictly less, so that causal connectability structure is exactly the right size to do that work. So this is time. And incidentally, this is the same result that you would get if you applied Craig's view. I think if you applied Butterfield and Gomes' view, it's the time-like direction in the manifold, right? Just a quick note, I'm not using the Hawking-Malaman stuff. It's actually kind of more straightforward if I'm allowed to, because you can just take a space-time and decompose it into the causal structure and then the conformal information, the scale information. And there are results that sort of tell you that you can do that decomposition and come back again. I'm not actually using that because I want this to apply in worlds with closed time-like curves, and that Hawking-Malaman stuff is restricted to worlds that are well-behaved, the past-future distinguishing worlds. But I think in worlds that aren't past-future distinguishing, you still have time. And so I have to do this sort of other thing where I'm defining out this causal connectability relation, but not this way, okay? Not just decomposing the space-time. Okay, there's lots of test cases that I want to handle. So I've talked a little bit about time versus matter, but I haven't really talked to you about the distinction between time and space. This does do it, but I have to strengthen the account to handle this kind of situation where space and time are necessarily co-instantiated. Worlds with just a single moment in them, talking about subintervals, dimensions, and ions, the A-series, it does handle a lot by this. This is what it ends up looking like a little bit. I have about as many bonus slides as main slides, so we can talk about some of that if you want. Okay, so this is the view, time is the great enabler. The account is compatible with time being all of these things. A B series, an A series, a C series, a fragment of space-time. It's also compatible with time being relational or substantival. I haven't told you about that. It's compatible with being linear or circular, discrete or continuous. All of those things are going to count because what matters is what it does, and what it does is enable causation and change, and lots of those structures can do that work. Coming back to space-time emergence, I feel like I now can look at a theory and work out whether there's time in there. If I look at causal set theory or blue quantum gravity and I see if there's a structure that's enabling change or enabling causation, then I'm inclined to think that there's time there. I think that this is going to mean that time is actually in a lot of those theories, because this is relatively easy. Okay, thanks.
Okay, now we're first, you're not only theoretically good in time, but also pragmatically, so thank you for that, so we're very well in time. Now let's welcome the comments by Marta. Let's go for 5 minutes, and then 5 minutes for the response.
Yeah, thanks. Thanks. I think like the paper was like the slide, they're like really thought-provoking, and I will try to keep it short. I have actually like many comments and questions. I will try to focus on the one that I feel like are more pressing. So let me start with, let's say, 3 worries, and then I will ask 3 questions. So the 3 worries are like, the first one has to do with the first condition and with the strengthening condition so like the idea is, I feel like these, if your assumption is that you want to be able to say that the B series is time, then you might have some problem with that, in a sense that like, you have, I don't remember which slide, I think maybe 15 or something, when you like specify the strengthening condition, you say like, oh, it might be necessary in all the, yeah, exactly. But like, so if you have a world in which you have like a B series, you also automatically get a C series. And I feel like if you want to say that like void with just the C series of time, because like that feature is enough to give you time, then you will have like some situation in which you have like, let's say the sufficient condition which has like the B series, you automatically have the C series, and then you have like some other stuff, let's say. And then you're like, okay, what's necessary in this for getting time? And if you want to keep like the B series, like then, I mean, like it seems like that's not really the best option, because like you also want to word it like even in void in which you have just the C series and like whatever other conditions, like you still have time. So like the question is like I feel like these slides, I mean for me it was a bit like misleading because you already have like T, while I feel like maybe having F like that just wouldn't be like better. So like if the question is like what's F in this situation, like in a B series void, I would say like, I mean probably you're gonna say like C because you want to, like the general account wants to claim that like C series is time, but then if you do that, you're not really able to claim that B series is time as well. Like you can say like you still have time, you do have time in void in which you have like the B series, but you're not really saying that the B series is time. So I'm not sure like whether it's a problem for your account, but in a sense like it seems like the settling condition can be a bit problematic in, like for the B series case. And well, another like general worry that I have with these insufficient but necessary part or components of a unnecessary but sufficient condition is that I feel like in many examples you just have like a kind of like direct necessary and sufficient condition as well. So I'm not sure how literally we should kind of like take this feature. In a sense, like if you just have absolute time, it seems like absolute time in Newtonian world is like necessary and sufficient for the structural possibility of causation and change. So I was just like the question is like how important it is to have like this insufficient but necessary and unnecessary but sufficient. And the last worry is on kind of like the applicability of your account to some like, let's say, specific case in which like you need to, you don't already know like what time is in that void. You need to kind of like be able to say like, yeah, there is time or there is no time. And if, so like take this example, like you have like a three-dimensional void, and you have like some solid, let's say, in this three-dimensional void, and the solid is, for example, let's say half white and half black and half blue. Let's say that like this part is blue. And then like I would say like, I mean, how should you interpret this word in like even your account? Because in a sense like you can say like, oh yeah, there is change along the x-axis. So maybe, I mean, the picture is like, I mean, like if, let's say like there is a structure that enables the structure possibility of change, which is just like change along the x-axis. But then like if this is just like a partial three-dimensional void, then, I mean, like the kind of change you have is a spatial change. But maybe this is kind of like a two-dimensional spatial void plus time. And in that case, you would like to say that there is time, like the x-axis is actually time. And it seems like you're not really able to kind of like make this distinction a priori just with your account without kind of like already assuming something about like, let's say, the role of time in this world. So, I mean, like I see like, maybe like there is a, I'm not sure if I want to frame it as a kind of like circularity problem, but it seems like if you just talk about like change, and the possibility of change, then it seems like you're already assuming something about like what time is doing in that way. So like let's say the functional role of time in like specific world. So yeah, these are my worries. The question, a bit more general. So the first one is, I see why like you're taking like the kind of like enabling change or causation, and I'm on board with that. But like I feel like since it's a disjunction, in a sense like you can add like whatever you want, well not whatever you want, but like also like all other reasonable feature like enabling temporal experience or whatever, without actually like losing, because you, at some point like you have it on the slide, you say like, oh, we don't want to add like too many things because like we want to be able to classify words in which intuitively there is time as words in which there is time. But like since it's a disjunction, you're not losing that. Like the risk maybe is to like over classify, let's say like to pick like more word than necessary. But at the same time, like I feel like if you have a word in which you have temporal experience, you might reasonably say that there is a sense in which you have time, or like something that has time there. So like, I don't see the cost of like adding more things, given that you have like this disjunctive definition. And I have a question about space-time emergence, in the sense that like I feel like if you, I'm on board with that, on the idea that you can have like time, like causal set theory, for example, like you do have a structure that behaves like time because you have like for example like the possibility of causation. But then I'm worried that like the consequence for space-time emergence is that like it makes space-time emergence not really interesting. In the sense that like then on top of that you also claim that there is an emergent space-time. And then, like, it's also making it a bit confusing because, like, the assumption, like, one of your kind of like underlying assumption is that space-time contains time. So then you will have like some like time at the, let's say, causal set theory level. Then you will have like space-time emergence, and then you will have like some time contained in the space-time. And then, like, for me, it's confusing whether like these time like contained in space-time is like, you know, I guess like given like your account would be kind of like some different F feature. So it seems like if you have like this time in a non-spatial temporal world plus space-time emergence, you will have like two different notion of time, which I think is like really not necessary in a sense. So like I feel like maybe like the conclusion you should get to is like, oh, we don't really need space-time emergence if we just have like this kind of like functional definition of time. And the last question is way more general about like modality and like how do you evaluate your account, because you have a lot of modal claims in your account about like structural possibilities, about like necessity, and like how do you evaluate like these modal claims within your account? Because it seems like the account is evaluated at one specific word, but also like you want to have like this kind of like possibility of evaluating modal claims, but I guess you don't want to have like your modal space to be like all the metaphysically possible words, because otherwise, otherwise for me it's confusing to kind of like have this multiple realizability of time. So just like if you can have a few words on like this kind of like how to think about modality, or how to think about evaluating modal claims in this.
Okay.
Thanks.
I'm not sure I can hold all of that in my head, but I'll see how I go. So here, the C series is not typed in the same way as the B series. I've got some slides on this, but I'll just try and be quick. So yeah, there is, I don't think that a C series is in a B series, because the temporal relation of the B series is asymmetric, and the C series is symmetric. Maybe you can define it out, but then it's going to be a different type, and the type matching clause is going to tell you that this is not that this is not a substructural part of that in B series world. If you did get the result that every B series world is not a world of time because it's got a C series lurking in it that does all the work, that's an interesting thing to find out. So even if that doesn't work, maybe it's okay. You said, why do the Inus condition thing? Why not just do necessary and sufficient conditions? I have defended a bit previously where time is just a thing that's necessary for causation and change and a bunch of other stuff. I don't like these views because I don't think that time is necessary for those things. but that's kind of an idiosyncratic view, so I don't think that time is necessary for causation, I don't think it is necessary for change, and so this is why I want something a little bit weaker, and that's what this weaker thing is supposed to do. It's supposed to open up space for interesting possibilities. This case where you said, how does my account apply here? Sort of depends on what's going on in this case. If this is just purely spatial, then I would kind of think that that's not change, and so there's no time there. If there is some change being enabled, then we can say that it's time, but maybe just a single instant of time. It does sort of move the question to what is change and how does that work? And I don't really want to have to answer that question, partly because I think it's going to end up being a little bit circular. You're going to say change is the thing that involves time. There's a sort of underlying worry here about how circular this account is because I'm specifying time in terms of things that are themselves probably specified in terms of time. I'm not too worried about that circularity. I see it as sort of the thing that you might do with causation when you can't give a reductive account of causation, but you can specify it in relation to other concepts that are interesting, and that's what I see happening here. Okay, remind me of the three questions just quickly.
So the first one is on why, if you have this disjunctive definition, like why you don't just add other features?
Yep.
Because it does like no.
Yeah, why not add other features? I mean, it is a sort of balancing act, right? You want to put in as much to get as many cases right, but you don't want to put in so much that you rule out good cases. I think a lot of the other things that I thought of adding in were either redundant or we're going to restrict it down in a way that was quite nasty, but if people have particular ideas, I can talk about that. Next, the third question was about modality. What do I say about modality? This is probably some kind of restricted necessity notion, right? So I'm looking at a world and looking at the worlds you can get to from that world, rather than looking at the full modal space when I'm thinking about the admissible configurations, but I'm looking at the full modal space when I'm thinking about which worlds have time in them. So I go to a world, I see what's accessible from that world to work out whether there's time there, rather than going to a world and seeing what's happening in the rest of the modal space. What do I think about modality? It's not going to be S5-ish, probably. What was the second question?
Space-time emergence.
Space-time emergence. I don't think it makes space-time emergence interesting. I think it might make it more interesting to find out that space-time, as in the thing that we have in general relativity, comes out of temporal structure. I think there's another alternative, which is that space-time comes out of space, and I kind of think that looks like what's happening maybe in loop quantum gravity or group field theory. And these are like different ways for space-time emergence to happen, and we've got different sort of pictures. I think there's still an interesting question as to how time gives you space-time, because you're getting the spatial component out of the temporal component. So I don't think it's uninteresting. I think it does potentially make it easier to answer some questions that space-time emergence raises, like things about how empirical access works, because you've got time and you've got that there to do that work. Yeah, thanks.
Okay, now we have 25 minutes for discussion. I'll ask everybody to just ask one question, and then if you have others, we can look you in the end, right? So Laura?
So thanks. There's a lot here, and so I'm trying to kind of get a sense of the project. And in particular, I just want to try to get a better sense of what you mean by enables. And maybe a way to ask you this is to set up like, so here's like, I say, this isn't that skeptical, slightly skeptical, sort of. Okay, so what if I want to know, like, well, what exactly what do you take causation and change to be? And if, for example, you think causation is just a certain kind of dependence, counterfactual, or maybe a kind of dressed up kind of counterfactual dependence, and change is just a property instantiated at one time, and then another different property instantiated at a different time. I'm already worried about using time in this case, so I'm puzzled about it. So there I'm like, okay, that's pretty minimal. Even there I'm using time in some way I'm not sure is consistent with how you want to use it, but at some kind of location, let's just say. Different properties at different locations. That's a very thin account. So then what is time enabling there? Because if I have this very sparse Humean metaphysics, then I'm not sure what time is doing to enable it. I've already got everything, and I think it's too minimal, but I've already got everything by my Humean lights. Okay. I say, no. Causation has a kind of dynamic, generative character. That's what causation is. We can capture it with dependence claims, but you've got to have that dynamic character in order to really be causation, because otherwise it's not generative in the deep intuitive sense that rationalists thought it was. And then change has to have also some kind of dynamic character, right? Some people think it involves past or whatever, but it's also not just conflicting qualitative characters at different locations. So each time I'm like, so what is time doing? What is the enabling part, given I've got either a very minimal thing, and then time kind of isn't doing anything special because I'm just so minimal. The other thing, it's like, I've already got these very rich things, so what's the enabling happening? Yeah, so that's my, that's one case.
Yeah, so I guess I think the minimal case is, I mean, there's just time there, right? So like you say, time's not doing much in that minimal case, but it is just providing a structure where you can have the counterfactual dependencies connecting each other, and you can have change in relevant sense. I mean, there is this sort of circularity worry about that, but I'm not so worried about that circularity. I think, there are ways of specifying what causation is that are very circular as well. Like take Woodward's account of causation, where he defines causation in terms of intervention. What's an intervention? It's a possible cause, so cause is defined in terms of cause. The value of it is that you understand better the kind of conceptual architecture of this notion and how it's linked to these other important things, even if there are sort of like mutual dependencies hanging around in there. I don't know if this is exactly getting at the thing, because you're saying, what is time doing? I think in that minimal case, it just is, even if it's just providing a structure of locations for counterfactual dependencies of the right kind and these variations, then I'm happy to say that's time.
So here, enabling is just, so you think that you can't define counterfactual dependence without time, and you can't give an account of change without time in the sense of providing what's meant by different locations.
I don't know if I'm saying that. Like, I mean, I actually might think that you can't specify counterfactual dependence without talking about locations, but I don't want to say that you can't specify counterfactual, like causation and change without using time. So that's why I'm rejecting this claim that time is necessary for those things. But when it does do the work of switching them on, then we get to say that it's time. These are difficult questions about how we look at the relationship between time and the other concepts that I'm linking it to.
Yeah.
And I think these sorts of problems often come up with functionalism, right? When you specify a functional role, you have to connect it to other things, and often those other things are kind of intertwined with the thing that you're specifying, so you kind of have to just have the whole structure as the thing that you specify, rather than trying to reductively analyze any of the components outside of that structure. I still don't think this is fully answering the thing that you're interested in, which is like, what work is time doing? But I think that the work is kind of minimal. It's providing a place for these things to happen, and I think it's unique in its ability to do that work in a lot of cases. With respect to the stronger like dynamicity stuff, if you want to analyze causation and change in those terms, that's fine. I think time can still be switching those things on. You could even like strengthen the account to specify that it has to switch on, causation change in these dynamic senses. I don't necessarily want to do that. I want it to be compatible with however you analyze causation and change. But this is coming back to, I think, to something that Marta was pushing towards, is like, how permissive does this end up being? Do you end up just making something so minimal that everything qualifies? It's really tricky to hit a sweet spot where you're doing something that's substantive and not like so substantive that you end up ruling out a bunch of cases that you want to rule out. Sorry, I'm not sure I'm directly getting the thing that's bugging you.
Sorry,
thank you. I guess I wanted to hear a bit more about how this then relates to what space it is in this picture. And this does sort of relate to circularity, because it seems change and variation are sort of really not distinguished.
Yeah,
but what is space? Could I have a sort of parallel account? Or space is what enables variation? Or you might, another thought you might have is, if you have space-time and you figure out what time is, then space is the rest, but that seems to be the conformal factor. So that doesn't seem, what does this sort of leave us thinking about space?
Yeah, it's a good question. getting time to split apart from space is actually quite hard. It turns out, using this sort of thing, and you can do it, but you have to sort of buy the following thing, which is that space can't enable causation and change on its own, and that's sort of what the difference is between time and space. Time on its own can do that work, but space on its own can't do that work. So there's that asymmetry, and then I've set up the account. Not the account that I've given you here, but the more detailed part of it to exploit that asymmetry between those two things. And yes, I can see the sort of like circularity issue like lurking in there. In terms of what space is, like, could you have a parallel account for space? I think you could. You could functionalize space if you want. I agree that the spatial part of space-time is not the conformal part. That seems a bit odd to say.
So in the relativistic case, what is it to remove space and see that you no longer have to change? Or to see that doesn't, I don't even know what it is. I'm trying to think
Yeah, it's really hard because
like,
I mean, even the sort of like metric, like the causal connectability stuff. I mean, I guess you can abstract the metric away from that, and maybe it's not that space is a conformal structure, but it's like the full metric structure or something like that. Whereas the temporal part is the like this sort of topology that's embedded in there. But I don't know. I don't have a good answer to the question of like what is space. I don't think that I want to say it's the stuff that's left over after I've worked out what time is, because I think that's going to get me weird results in a bunch of cases. But I don't have a positive account of what space is. But I think it invites a positive account, and that's kind of fun. We spend a lot of time thinking about time, we don't spend enough, maybe, time thinking about space.
Yeah, so I think my question, given the last few questions, is highly unoriginal. Because it was also about change, and about like circularity worries and that. Let me just rephrase it, and maybe you have exactly the same reply and I won't blame you. But so if you have just change like across a region, right? So we have a change in temperature gradient because it's hotter here than it is outside. I don't know, like then like obviously that's not the type of change you want to target. And then the first like suggestion I thought of was like maybe you could have like a difference between, so you have a predefined notion of spatial change or something, spatial variation, and then you kind of exclude that from your definition of change.
Yeah.
But I don't think that also works with like, so I'm just wondering like in what sense is time really enabling change? And it just seems that time is really enabling temporal change, and then what is time enabling? Time is enabling time. Like it seems like really, really thin at that point. Like if it's, especially if I'm just like a committed four-dimensionalist, I'm like Cyber and in its most extreme form, and I just think that like all the spatial things have temporal analogs, and there's really no difference between them. The spatial part and the temporal part, and like the fact that I use all the temporal parts I can only do if this axis is already pre-labeled or something like that. Like why, in those sensitive reasons, like the dimension is just like primitive and there's nothing else to it.
I mean, I guess, like I think that if we have to define change as, you know, having different properties at different times, that's okay for the account, because I'm not trying to give you a reductive analysis of time. I'm happy with something that's not reductive, that has this kind of, you know, mutual dependency between the concepts. I think that we can define something in terms of another thing does not mean that they're the same thing in the relevant sense, right? I think change is something different to time, even though we might specify change in terms of time. So I don't think it ends up, if you say that time, you know, enables change and change is specified in terms of time, that the view is that time enables time or something like that. We're still getting something that, even if it's specified in terms of time, conceptually, we're still getting something from having the temporal structure that we can't just get with the spatial structure. You know, there's this hard question about what the difference is between spatial variation and temporal change. I don't know what the answer to that question is. I think we all kind of assume there is some distinction, and as that's sort of enough to, I think, get this account going, as long as we're happy to have that distinction. But I don't have anything like particularly insightful to say about the difference between those two things. We might have to specify, you know, we might just end up in this kind of circularity type situation. I mean, think of it this way. As soon as you start to like try to answer this question, what is time, and you like want to think about the relation to change, it's really going to be very hard to avoid this circularity. So I think there's going to be lots of accounts of what time is at this level that might go in this direction. Even the sort of Craig calendar account where time is the graded format, it sort of like bakes in dynamics into that account, and so time is sort of specified in terms of how things dynamically change and the simplicity and informativeness of that dynamical change. So it's sort of in there as well. In the Gomes and Butterfield account, it's like change in spatial geometry is the account of time, so it's in there as well. So I think that this is, once you start doing this functional stuff and you want to, like, change is such an obvious thing to link, it's really hard to avoid the circularity, but I think it's okay.
Right, so I don't know who was first. I'll give it to Erwin just because we traveled long. Yeah.
I don't know if that's a good
So we have 15 minutes for 4 questions.
Alright, I'll just keep it quick. Yeah, I was just going to ask about the space-time case, and so the argument there was that the causal structure is kind of all you need for qualitative change.
Yes.
Yeah, I don't know, maybe I just don't have a great handle on qualitative change.
Yep.
I was just thinking about cases like where it seems like you need to appeal to metric structure to explain what seem like qualitative changes. I mean, like, think of like twins paradox or something, like someone being older than someone.
Yes.
Seems kind of qualitative. It seems like I need to appeal to the metric structure to get that. I need more than just causal structure. But maybe I just don't know. Maybe I'm just asking for a little more info.
Yeah,
What do you mean by qualitative change?
Yeah, I mean by qualitative change, I mean like which causes happen, which changes occur. I think in the twins paradox case, you're going to get the result that like one is older than the other one, but then the metric tells you by how much in that situation.
Yeah.
And so it's sort of like, it's that extra information about like how fast or slow these things happen, what the actual distances are. That
How do you even get the qualitative difference that one is older than the other without appealing to the metric? Is there some purely qualitative fact that I can tell about in terms of purely causal structure there? I'm kind of just not
well, I mean, there would be
seeing
other features about them that would.
one accelerates or something.
Yeah, there'd be sort of other features, I think, that would be part of the facts that we're pinning to the structure, I think, that would differentiate. I need to think about the twins paradox case. I just hadn't thought about that one.
Yeah, I guess I was just thinking like the metrics playing an essential role to even there being any difference between the two.
I'm not sure it is.
Okay.
I guess is my thought. I feel like there's a way to specify the difference just in terms of like the causal structure
Okay.
without doing it with the metric. But I need to sit down and think about it.
Thanks. I think it's a great proposal. So the question I have is that should I decide whether I want to be on board with you or not for the what is time question to approach space-time emergence? And so I think maybe not. So okay, we have this trinity of questions: what is space-time, what is space, what is time? We would like ideally to have answers to those questions. And then we have this question about space-time emergence. How do we, I like to think of that in terms of explanatory gap, how do we relate the fundamental ontology, let's say, to the derivative ontology? I think the way you present things is quite suggestive that it will help and open new questions to approach space-time emergence, to become a bit clearer on what is time, and perhaps using your proposal. And I guess my question is in relation to our previous paper, space-time quietism in quantum gravity. Because one thing you might do is to say, well, I don't need to reply, address those 3 questions, what is space, time, space-time, to try to make progress on how to relate the different properties that are at cause between the fundamental and the derivative. And so I was wondering, how do you approach the relation of your new project to that? What would be the reason not to be space-time quieties? So basically, you say there are many proposals, we don't need to pick one, and a time quietist and a space quietist to approach space-time emergence and address the interesting questions. Because in a way, you could, I mean, Niels has a great idea of what really matters is the split between space-like directions, time-like directions, or something that's sufficiently similar. So I think, okay, maybe we just need to answer distinction between something that looks like time, something that looks like space, without providing an answer to what is exactly time, what is space, and what is space. So I guess it's kind of my big thought on that. But yes, what do you think of space-time poietism and time poietism in this setting?
Okay, so space-time pietism is the view that we don't say what space-time is, roughly. We sort of refuse to answer the question, what is space-time? You know, I mean, you can do it sort of like, what is space-time in general relativity? Maybe you can answer that question, but what is it like in a theory-independent way? You sort of refuse to answer that question. You might think we should do the same thing for time. We refuse to answer the question, what is time? We refuse to answer the question, what is space? I guess part of what's motivating me about all of this is that I want to know if space-time is emergent, even if it's just the local sense, like we're talking about the thing in general relativity coming out of something in some more fundamental theory. I want to know what it could be coming out of, metaphysically speaking, right? We can build mathematical models of what that looks like, but then there's this question of like, what is the metaphysical category of the world at the most fundamental level if it's not space-time? And I think at that point, you know, very natural questions like what is time, what is space, what is causation start to arise, and you kind of, I think it's, if you don't answer those questions, you just go quiet on those questions. I don't know what metaphysical resources we have anymore to even specify what the fundamental nature of reality is like. And maybe we just shouldn't do that. Maybe that's just a thing that we should refuse to do. But then I'm sort of lost as to what it is that we're doing, at least metaphysically, with respect to thinking about space-time coming out of something else. So I don't want to be.
I think I'm with you. I think we can sharply distinguish the two layers. I think there is one layer of interesting questions we may ask before going to this, what I call the Trinity, the three questions. I agree with these interesting questions, and we should do that job. What I was just trying to say that maybe it's more like some cool work that can be done in the context of space and emergence, but more after. Some other questions could be still done before having to take a stance on those questions. It's incompatible with the fact that it's a great project, it's super interesting. It's just that some of the issues may still be tackled without taking a view on that.
Yeah. I mean, I guess I'm not saying this is what we ought to be doing. I say that this is what I am. For better or worse.
Okay, Chris.
Thank you. So first a comment and then a question connected to that. As a follow-up to David's question, I don't see how you could possibly determine the difference between the proper time of all different world lines without using metric information. And that leads to the question I originally had. It seems somewhat arbitrary to me to insist that somehow the qualitative features are essential and the quantitative are not. I think that, you know, is it really, I mean, by virtue of what do we think we have hit the sweet spot, as you call it? And why not insist, which seems just as justified to me, that the structure that time should be richer than that. It should not just have some ordering information and things like that, but also metric information.
Yeah. I agree you're not going to be able to specify the proper time without the metric. I guess what I was thinking was whether that means that there are change facts in the sense that I'm talking about that are coming out of that metric information. So whether these like older than relations are change facts in the right sense. And what I was thinking is that all of the relevant change facts where it's just, okay, you know, take change to be just property variation across time or something like that. Maybe all of those facts are still there, and maybe we can reconstruct a kind of older than thing, even if it's not to do with like specifying the proper time. But I need to think about it in a little bit more detail. It depends a little bit on what it is to be older than someone in that sense. In that case, I mean, there are differences between the two people depending on their proper time world lines and the sorts of things, changes that they undergo. And so that might be enough to rebuild something, but I need to think about it. The deeper question is this question, like, why not include all of that qualitative information? I mean, the simple answer is that I'm not going to be able to pull time out of space-time using this account, right? It's really engineered to try and look at what it is that light cone structure of relativity is enabling, and then use that as the basis for specifying the temporal component. And as far as, like, my thought was that that it is enabling sort of which causes can occur, but it's not enabling kind of parameterization of those causes and those changes, and that's something that the full metric does. But you're right, like, you could just think that you could beef up the account, right? Then I think you get this result that space-time is time. And I don't like that, but maybe that's just something we could swallow on this account. You would also force time to have metric structure, probably. And then, you know, causal set theory would not be a theory in which there's time lurking down there. Look, I think that I'm more attached to the slogan than the specific way that we work the slogan out. If there's a sort of version that works for you, then feel free to beef it up and run with it. But I think there's a question about whether, you know, there's any version of this, precise version of the slogan that's actually going to split time from space-time in a natural way. And maybe not. Like, I was hoping that this distinction might do the work. Is it arbitrary? I don't know. Is it any less arbitrary than time is the great informer, or time is the thing that parameterizes spatial change? Those are sort of reverse engineering as well, I think. But I take the point.
Yeah, I was just say two things. One is a comment on what David and Chris are asking, and another one was a question. Because I was thinking, one way you might go about getting out of this kind of weird pickle to spread yourself in with respect to the proper time in between paradox could be that you could try to use causal relations to define a clock length. So you could say basically, I am an observer, and I fix 2 points on my word line, and I use I mirror somewhere far, and I just launch some photon there, and I make it come back, and then I just stipulate that that length is like 1 unit of length. And then both me and my twin, we basically define clocks which measure 1 unit of length as the kind of whatever gets measured by this process of going up to my mirror and coming back, and I can make it as small as I want. We're going to put the mirror on the other side of that room, and then I will measure like seconds. And then you just give them, and now you have clocks, and then you give them clocks, and you get the paradox, and you get the twin paradox out. So it's maybe a bit convoluted, but like you basically define clocks in terms of null curves, and then just stipulate that the length measured in this way is just the interval that the clock measures, and then you should be able to kind of recover most of these facts. More on the question side, I was wondering something along the lines of what Nick was asking regarding the role of space here, because when I was looking at your analysis of GR, I was wondering the following thing. So I'm happy to follow along with this idea that we have this causal structure and it fixes this notion of change. It strikes me as kind of a formulation dependent to some extent, because you could equally reformulate that whole situation. So you had a situation where a model of GR is a manifold and a metric. You could reformulate it in some kind of Hamiltonian formalism for GR. And now all of a sudden a model of your theory would be a 3-manifold or a 4-manifold with a 3-matrix or a spatial metric and some constraints imposed on it, which are imposed on the 3-metric itself. And they just serve to assure you that that is kind of like the initial data on that is suitable initial data, but in some sense that fixes everything you need. And you've suddenly reduced your problem to a 3D purely spatial problem. Or you could even, there are some cases where you do this but with null surfaces instead of spatial surfaces. So I'm kind of wondering what happens to this account if I'm just an Hamiltonian person and I want to write this stuff down, and how do I find time in that?
Thanks for the clock idea. I mean, that's really helpful. I mean, so I wasn't thinking of the case where we can cleanly split the metric from the, take the causal structure out and then you do the Hawking-Malman thing and specify space-times in terms of two components that you can cleanly slice out. And what I'm wondering is if the Hamiltonian formalism is going to, like, does this work for every model? I think it only works for these sort of well-behaved ones, right? And I want this to, so my thinking is that in those cases, you can still specify time in the way that I have, right? You could say that it's the thing that enables causation and change, but I want the more general account because I want it to handle worlds with closed time-like curves. I still want those to be ones with time in them, and the sort of Hamiltonian thing isn't going to work there, I think.
Yeah.
So that's why I'm doing it in this way. But I think if you wanted to just specify some initial data on the surface and then, extrapolate the rest, I think the axis along which you do that extrapolation is going to be the axis along which causation that enables causation and change in the same kind of way. But I guess I don't want to hang anything on that because that feels like a choice of coordinate type way of doing things, and I wanted to apply more to the gauge-free sort of feature.
I would just like to get a sense of how epistemic or ontic your account of time is. I have a sense of both the slogan and your specific way of spelling it out, and also depending on how you spell out generalization and location and so on, that it could be both an epistemic account of time and an ontic account of time. Do you think of yourself as being committed to one or agnostic? That might be a strength of your account.
Look, I want to be doing the ontic thing.
Okay.
Because I have metaphysical bones, and epistemology freaks me out. But there is a way of reading all of this epistemically, actually, even the multiple realizability plane, right? So I read it as there are these worlds in which there is an A series or there's a B series, and you want to handle those worlds. But you could take it to mean that there are these epistemically possible scenarios that apply to the world for all we know, and then this is an account of the sort of concept of time such that it handles those epistemic possibilities, and then it's going to look something two-ish. It's going to be. So Dave Chalmers actually has a functionalist account of time, which I didn't really talk about. He gives it in one line in his massive Constructing the World book, but it is sort of explicitly epistemic in this way. And this would be a sort of refinement of that view if you took it epistemically. I don't particularly want to, so I'd prefer the ontic account.
I wrote it.